All right, y'all, welcome to the video where I do the calculator active section of this FRQ review. Here we have an FRQ1. We've got a figure F shown in the graph up here, and we've got another function G that we'll need to graph. This is very typical for FRQ1. And we have a function H defined as the G of the F of X. And we want to find the H of 3. So I'm going to start by finding the F of 3 since that's the innermost part here. And the F of 3 is 2. So all right, the F of 3 equals 2. That 2 then becomes the input to G. So I'm now looking for the G of 2. This is a calculator active, so all I need to do is pull up Desmos, and I'm just going to define the G of X. It is equal to 2 plus 3 times the natural log of X. Don't do this thing where you substitute into X. It'll be a lot easier for your workflow if you just now type in a different box the G of 2. And it outputs 4.079. We're always going to round or truncate at 3 decimals. So we get the G of 2 equals 4.079. All right, that's an easy point. Find all the zeros of F or indicate that there are no zeros. Well, the zeros of F are just when we hit the x-axis. We hit the x-axis right here at -1, so there is a 0 at x equals -1. Just always double check which function it's asking about. It asked me about F, so I need to look at the graph. If it asked me about G, I would look at Desmos. Find all the values of x as a decimal approximation for G of x equals E, or indicate that there are no values. So now we're getting asked about G again. Well, I'm just going to graph the line y equals E. Remember, E is a constant. It's a number. And we can see it intersects at about 1.2705. I'm going to round that 5 up at the end, so 1.271. 1.271. Okay, determine the end behavior of G. So we're getting asked about G again. As x increases without bound, express your answer using the mathematical definition of a limit. All right, so let's look at our graph. Well, as x is going to the right, increasing without bound, where is the output headed? Well, it's going up, slower and slower and slower, but it's going up forever. So it's headed towards infinity. So I can say the limit as x approaches infinity, the G of x is equal to infinity. All right, determine if f is invertible. That means, does it have an inverse function? Well, let's look at it. We're looking to see, does it fail this horizontal line test anywhere? Right? Is there anywhere I could draw a horizontal line and hit more than one point? It doesn't look like it. If you flip this, if you take your paper and just kind of flip it, you'll see that there is nowhere. So yes, this is invertible. Yes, f has an inverse function. All right, give a reason for your part answer. Now, the College Board is very clear. Saying it passes the horizontal line test is insufficient. So it says refer to the graph in your reasoning. So I'm going to say all output values. I'm referencing the output values first because the outputs become the inverts in the inverse function. All output values, or maybe I'll say no output values, are mapped to more than one input value. All right, so that is pretty easy. I actually want to take a second here to cross-reference. Hopefully I did everything right. to check our answers with the scoring guide. So I've also saved the scoring guide here. And you can see first one follows a very similar workflow as us, gets 4.079, so that's good. They also got x equals -1, so you can see 1 point for that, 1 point for that. We've earned 2 points on A. Let's go back and look at our answers for B. We had 1.271, and we has as x goes to positive infinity, g goes to positive infinity. Let's cross-reference those with the answer guide. These are ones that are pretty easy to score. You could have gone with 1.270 or 1.271. The answer alone gets you the point. So if it says answer or value, all you need to do is have that. You don't need an explanation. And yeah, here's the end behavior with limit notation. It says if you have end behavior with limit notation, you get the point. We have that. So we've scored 4 out of 4 points so far. Let's see if we got the last two. F is invertible. I said F has an inverse. That's the same thing. Again, you just need the answer here. And now we need a reason. Each output value of F is mapped from a unique input value. So unique is probably a pretty good word. Each has a unique input value, okay? And again, we're saying output first instead of input first because the input and the output are switching when we invert the function. Catch this right here. A reason that only states does not pass the horizontal line test is not sufficient. So please don't use the words horizontal line test in your answer. All right, so that's FRQ number 1 of the calculator active section. Let's jump over to FRQ 2 of the calculator active section. It says in 1970, the College Board began offering separate AP exams for AP Calculus AB and AP Calculus BC. In that year, t equals 0, a total of 14,379 AP Calculus exams were administered. In 1983, t equals 13. A total of 35,489 AP Calculus exams were administered. The total number of AP Calculus exams administered in a given year can be modeled by the function E, given by the E of t equals AB to the t, where E of t is the total number of exams administered in year t, and t is the number of years since 1970. All right, so we are probably going to use a regression here. If you're familiar with FRQ2, it will always start with this. Use the data to write 2 equations that can be used to find the values. Well, we have 2 sets of inputs and outputs, so we can write 2 equations. We have an output here, matched with an input of t equals 0. So we can say, okay, we have the equation 14,379 equals AB to the 0. And then we have our other equation, which is going to be 35,489 equals AB to the 13. So just sub those in. Those are easy points. Now we want to find the values of A and B. You can do this algebraically, and it's a good skill to have, but we're just going to use Desmos. So we're going to open up Desmos. We're going to clear this out. I'm going to add the table. And we have, what was it? At year 0, I believe it's 14,379. And year 13, it's 35,489. Now, because this is a perfect exponential function, y equals AB to the t, this is the standard exponential function, I can just click on the regression button and go to exponential. If it wasn't, I would have had to do y1, where's the squiggly? Squiggly, a, b to the x1. And you can see I get the same answer choice no matter what. This second method will always work no matter what the type of function. This drop-down menu only works if it's a perfect regression. If it had a k, for example, let's say it had a plus k, I would have had to type k. I would have had to type this. So just be careful with that. Because this is perfect, I can just use the drop down though. So A is 14,379. A equals 14,379. And B equals, I'm going to round this, 1.072. 1.072. 1.072. All right. So now we have our A and B. These are pretty easy to get. Part B of FRQ2 is always going to ask you about average rate of change. Remember, the average rate of change is just going to be equal to the change in Y over the change in X. So I'm just going to use my calculator. Well, obviously I know 13 years went by. But how many, what was the change in Y? So I'm going to need a calculator for that. We have, watch how I do this. I'm just going to put it in parentheses because I know I'm about to divide the answer. 35,489 minus 14,379. And if I close this, all right, so that's 21,110. I'll just write that right here. It says show the work, so I am going to show the steps here, 21,110. And then I'm going to divide that. Obviously, I could have done this all in Desmos in one step, but it says show the computations that led to your answer. So I'm better show the computations that led to my answer. So what I'm going to do with that number, I'm going to divide it by 13, and I get 1623. 1623 point, what was it? 846. All right. So now we're going to use that average rate of change. B2 is always going to ask to use that average rate of change. I think I gave some bad advice on the past in this, so listen close, listen close, listen close, listen close. We do want to create a linear function, but we want to use the most recent data that we have available. And the most recent data that we have available is in T13. In this example, using t equals 0 would work, but it won't work in every example. So I want us to get used to this. So in T13, we were at 35,489. We are adding 1,623.846 every year. So I would make this a linear function and just say every year. But how many years have gone by from t equals 13 to t equals 24? Well, that's 11 years. So I can say, okay, how many times does it go up by this amount? It goes up that amount 11 times. Again, it says show the computations that lead to your answer. So I'm showing my work here. So now I can type this in. We have 35,489 plus 1623.846 times 11. And I get 53,351. Depending on where we round this, I'm curious what the answer guide's going to say. And we might come back to talk about this, but we're going to call it 53,351. 53,351.306. I'm a little concerned about the decimal here because I used a rounded number in my answer. We'll see what the answer key has to say about that. Okay, so now we've got 4 points. The last two are a little harder to get in this one. Consider the average rate of change from t equals 13 to t equals p years, where p is greater than 13. Are the average rates of change less than or greater than the average rate of change from t equals 0 to t equals 13 weeks found in I? Explain your reasoning. So let's look at our function here for a second. We are looking, well, all right, let's just look at it for a second. This is clearly a concave up function, right? It's a concave up exponential function. And so what does that tell us? Well, that tells us some important information. The rate of change is increasing. The rate of change is increasing. So as t gets larger, the rate of change gets larger. So what is it asking us? Consider the average rate of change. Are the average rates of change less than or greater than the average rate of change for t equals? Well, they're greater than. So the average rate, don't abbreviate, but I'm just doing it here for space sake. The average rate of change is greater for p is greater than 13 because the graph is concave up. All right. C. Due to the COVID pandemic that began in spring of 2020, the Model E can only provide reasonable estimates for the total number of AP calculus exams administered in a given year through 2019. That makes sense. Explain how this information can be used to determine the limitations of the range. So range is all the possible output values. And here it's giving us a limitation on the domain. This function only works until t equals 49. And so what does that tell us about the range? Well, I'm curious how they say this. The upper bound of the range is equal to the E of 49. That's my lazy answer for now. Because the domain reaches a max of 14. The domain reaches a max of 49. Let's see if that's sufficient. All right, let's look at the scoring guide. All right, there's the two equations. Those are really easy to do. So that's an easy point right there. A and B, you can see they did the algebra. You don't need to do the algebra. It says right here, exponential regression. Here's what you get. That's what we got. So those are easy 2 points. These are also easy. And yeah, it looks like we're good here. We got this average rate of change in y over the change in x. That's the exact workflow that we showed. And here, this looks to be pretty good as well. It's an estimate, so even if our rounding was a little bit different, I think we had 3.06, should be correct. All right, the average rate of change of E from t equals 13 to t equals p after years are greater than the average rate of change from t equals 0. Because E of t is an exponential growth model, which is concave up. The trains are increasing. So this word concave up needs to appear in your answer to get credit. And that's a point. All right, let's see what it says for this one. The domain limitations from t equals 0 to t equals 49 for the model E of t will limit the range. So I think, well, I didn't provide a number. So maybe that's better to plug that in. I don't know. We're all doing the best we can here. Okay. That is the FRQ2 section that is the calculator active section of this mock FRQ. I hope this video